Yeah, so I'll kick things off. Whichever point can start.
Hello, the ICTS member. This is not on Zoom. Is it coming on Zoom? Can you please check?
Maybe one of yeah. Yeah. Go on. Should we? Jayanta, should we begin? Oh, okay. Yeah, all right. I guess we can get started with the discussion session today. So I guess in the morning we had some really fantastic talks, that kind of demonstrated the capabilities of Spotlight, and when it's going to come online, it's going to be able to do some really, really neat science in the landscape of fast transients. And I think that kind of begs the same question that the community has been struggling with over the last few years, which is that we are now in this era of rapid, this discovery space where we're getting crazy amount of FRBs, across these wide field radio surveys. And the question now is that, we really need a framework, right, to rapidly kind of analyze our data, not only that, and promptly follow up these FRBs at multiple wavelengths, identify host galaxies, estimate redshifts, and so on. I mean, 5 to 10 years ago, it was easy given that we were finding one FRB every 6 months. Now we are finding one FRB every day. So it's like orders of magnitude change in the discovery rate. And as I've put there kind of some rough numbers from Spotlight, right? I mean, even with maybe 300 or 600 beams, we're talking about 10 FRBs a year, but when they'll be fully online with 2,000 beams, we're talking about 2 FRBs a week. Again, that's a pretty decent discovery rate. And so we have been, we have been thinking about, what possible directions can Spotlight go from now, in order to enable like the best possible science. And so I just to get this started, I just have a couple of points here, right? In terms of two things. One is multi-wavelength follow-up for these fast transients. And secondly, some technical capabilities that could be improved to take us into the in the next decade of next generation instruments. So I'm going to open the floor here to the panelists first. So we have Franz, Sunil, Kriti, and Prabhu. Yeah, so if anyone wants to comment on any of these or have any thoughts about any of these points in particular, yeah, the floor is yours.
Okay, I'm holding on the mic first, so I'm going to go. I was thinking along the lines of follow-up strategies for observations of fast radio bursts. So one thing that would be super useful to have would be a framework where once you have localizations, it would be ingested into a unified like website or a platform where you keep track of all of your FRBs. So in Chime we have something we call Chime FFPZ. It's FFFFPZ. But it's basically adapted off of what the Easy Peasy Supernova group have been doing. So and it's essentially a database of our FRBs that we ingest as soon as we get localizations from the radio team, and immediately afterwards, there are automated scripts in there that help us plan our optical observations and allocate resources that we have. So in terms of telescope time, and like any other, like what do we need imaging? Do we need spectroscopy? That sort of thing. It's super convenient to use this platform for that work. And subsequently, if you want to do any sort of multi-wavelength follow-up, we basically first look for existing catalogs of optical imaging, optical spectroscopy, X-ray detections as Z effect, all sorts of catalogs that we could easily search given our coordinates. And some of this code, or most of this search code is already available in the FRB repository. So I'm more than happy to interface with the Spotlight team and see how we can best make use of the existing framework for Spotlight's benefit. But yeah, basically, there's a lot of resources, and I think when we're dealing with 2 FRBs per week, it would be nice to have a very systematic approach to follow-up observations.
Just along those same lines with the multi-wavelength follow-up, I mean, the important thing is always that you want to have commensality also, right? So it's always great to go through catalogs and go back and see those, but you know, I think it's important that we try and get to that commensality so that there is some, even just a simple optical dish that actually monitors or just covers the same field that CHIME does at any one, not CHIME, the GIMRA, you know, with FRBs and CHIME, that's sort of one thing in my head. So, you know, anyway, that's something that covers the field of view that the GIMRA T does at any one moment in time, something simple that, you know, some CCD that does something. And then you could even, you know, if there is a detection in one field, but you must have probably covered that field before, and then you can even go back, what was there, you know, a week before we actually had the detection. So I think commensality is really important. I mean, commensality with X-ray is going to be difficult, but you know, commensality with other radio stations is probably possible. The chance of having that is actually easier, I think. And some optical, I mean, yeah, or collaboration. I mean, there's collaborations with. So I think the Parks people in ASCAP, they have some sort of collaboration with some quick optical follow-up going on already. So this is definitely a direction to go into.
Yeah, I guess, again, also on the follow-up perspective for Spotlight specifically, I think it might be worth identifying the specific science cases where Spotlight holds an edge compared to all the other experiments. For example, I was looking at the expected dispersion measure distribution of FRBs, and seems like Spotlight will be able to push it all the way up to Redshift 2, perhaps. So probably like going after those high DM events and keeping track of all the follow-up that you're doing in a systematic manner might be useful. For example, in our case at DSA, we have a lot of high DM events, and we've had multiple follow-up efforts to try and get a redshift. And at some point, it tends to get difficult to keep track of what all observations we have. So probably having some interface like what Sunil suggested, or something similar to Fritz, for example, in case of ZTF would be useful.
Yeah, good afternoon. And I think I will talk a little bit on all the points, particularly the fast image pipeline searches. These are something, the new techniques that needs to be developed, augmented with accelerated processing hardware. And we do have very good infrastructure in the country as well as across the globe. People have been using multiple different accelerators. And that will be definitely a useful thing to go and keep looking for these slow transients, and that's something that one may not want to miss it in the middle of all other fast transient search and algorithm development. In fact, these algorithms will work reversely, so one has to be careful we don't miss the slow transients. And technical upgrades, point number 2 is something that it's close to my heart. I will tell, I think going from 160 to 640 beams and drawing 130 kilowatts power for the IT, which is 4 times the current infrastructure power for GMRT. And in 3 years, it will be complete. And in my view, you already have a huge capability that is required for the next generation GMRT. Okay, so things are there and very well tested, and it's up to our imagination to make it available for a larger number of users, not just for the FRB. And so that brings me to the point, think beyond 3 years. What kind of upgrades? And that may need to be thought about in a manner that it attracts attention of the larger community, not just the FRB. FRB may get solved sometimes. And you'll have more focused, very specific hardware will come into. Keep the broader view, and who else could be the users, and that users get attracted and benefited, and plan for what could be the upgrade. And that's something that's very important. Multi-wavelength follow-up. In country, we do have X-ray telescope, and there is cosmic ray shower detection facilities. And we do have a gamma ray telescope coming up. And this is an opportunity, and which points drives us to the next point, the trigger. So a community need to evolve to share informations very quickly and provide, it has to be seen as a global problem, and share the triggers and have facilities to even not just an out trigger when GMRT gets it. GMRT field of view is at that point, any instant is small, and we need to have an out station which could give even GMRT an information about the potential triggers, which is not very hard. As you know, it's not a very big instrumentation. So that is very important. I think one needs to have it. Coming back to the, again, multi-wavelength, we have a very well-established IIA facilities in country. And it's broad possibilities exist. So I think one needs to coherently think, and I will come back to it later in the next.
All right. Yeah, no, I think it's a good point you touched on, Prabha. I think especially with, I think we need to figure out what's the best way to make good use of all the astronomical resources that India has, right? I mean, it's a big country, right? And so we have places with good seeing. So which means it's potentially we can build some really very sensitive optical facilities, or make use of the existing ones with better instruments. Personally, because I'm not an optical astronomer, I don't have a good idea about what the capabilities are of existing instruments in India. Maybe Sunil or Kriti, you have a better idea. But I think that also kind of applies to the last point, right? I mean, India is a huge country. I mean, you have 3,000 kilometer baselines at your disposal. So, you know, can build a few outrigger dishes and get that VLBI going just within the country itself. And I think that's a massive opportunity to really maximize the science. Yeah, anyways, yeah, that's all I wanted to say. I don't know. Anyone else wants to? Yeah.
That works. Okay. Yeah, I mean, I spoke with Jayanta about this earlier as well, and I fully agree. I mean, you know, detect your first 10, 15 FRBs with Spotlight, and then I would directly go for funding, or try to find funding for 2, 3 outrigger stations. It doesn't even have to be as big as a GMRT dish, right? It can be just a 25-meter dish, because you have the core, and then you just need those baselines. It can be a pretty simple, cheap outrigger stations, I reckon, that just, you know, cover the same field of view, and then you directly have those 3,000 kilometer baselines, north, south, east, west. It's no. That's something I would definitely encourage to do, because I think it's great. The chances are awesome. And then, but one more aspect that I wanted to touch upon is the with the technical upgrades, larger bandwidth, and so on, because you know we know that FRBs are patchy, right? The spectrum is patchy. So you could also think about within the pipeline from early on built-in sub-banded searches, right? Because we've seen this with the ultra broadband receiver at Parks. They had an FRB that was 16 megahertz in bandwidth across a 4 gigahertz full band or something like that. I might be getting the numbers wrong, but you know, the sub-banded searches, and even then when you go from the sub-banded searches, you can also think about expanding the parameter space. I mean, currently you got 1.3 millisecond visibilities, and I think for localization that's great. But in the time domain, depending, I mean, you have a big cluster, there's a big compute power. You could also think about trying to go to higher time resolution searches, right? Because we've seen these microsecond sub shots. So looking for those. So the long period transients, you want to do those, and you also want to do the super short ones, the microsecond level bursts in sub bands. I know it's a lot of compute, but since you're building the pipeline, you're in the middle of it, could think about adding that, if not now, but keep the door open to add that in the future.
Yeah, so I think, again, with the LPTs, right? I mean, again, we seem to think now that most of these have optical counterparts, right? So it's only going to put more pressure on follow-up facilities, at optical. So, if there's one kind of, survey that's going to find a lot of LPTs and a lot of FRBs, I think it would be very useful to have some sort of an optical facility that they have access to that can do some prompt follow-ups for these things. Because, I mean, just from experience with Meerkat, already with 5 to 10 FRBs, we're having problems. I mean, it also doesn't help that Meerkat keeps finding really high DM FRBs, and you don't see any host galaxies in any of the existing catalogs, or sometimes even in Keck observations. But I don't think that would be such a big problem, at least for Spotlight, because for Spotlight probably sits exactly between where Meerkat is finding FRBs and where most of the CHIME or ASCAP FRBs are. So it should still be possible with a kind of a semi-big optical telescope to kind of achieve the same goals. But so I think, pretty important, I think. So I think in the last 10 minutes or so, I think we've spoken, a bit about the last four. I think I'm just going to open the floor now to everyone. If anyone has any questions for the panel or even comments, please feel free. Don't feel shy. Safe space here. So speak your heart. Oh, no, can you use the mic, please?
No, just the triggers you can, I think Chime has started to do that. For the Spotlight triggers, you can put on VO event and on GCNs. So all the high energy telescopes and even optical around the world will get that. We have 2 telescopes like Growth India and HCT. I think they already listen to GCNs. So anything counter, like Growth for sure, I think will be able to slew in few, automated time. HCT probably difficult, bigger one. But I think that would be important. I mean, Growth not that sensitive, but when it comes to very high Z, but maybe but nearby it might just be not doesn't harm basically. But ingesting GCNs is very easy. I mean, the GCN team has put a lot of efforts now to make it the interface very easy. So sending triggers to GCN is 50-line code or maybe not even less probably.
Any more comments, questions?
Am I audible? Yep. So to generate more science, we need more users for your data. So are there any plans to make data publicly accessible, or is it gonna be accessible for everyone? Sorry, it's for you, Jayanta.
Okay. So currently the thing is that the GMRT has a any observation which happened on GMRT has a 18-month of priority period. Okay. So after 18 months of priority period, any GMRT data is publicly available. Currently, the same thing applied for Spotlight also. But only thing that Spotlight, the data which will be recorded is already pre-detected. So you are not recording anything blindly. Whatever the baseband data or the voltages or the beam, they are only getting recorded from the commensal part is where there is an event seen by the system. Okay. So that data will come up. Current policy which you have set up is same 18-month periods applicable for those data to come up. The data which will come up as the open sky where the PI requested, they are also same thing will be same policy applied. Okay. Is log 18-month. We have a smaller time scale for the DDT and TAO because those doesn't stand for 18 months. I think they just stands for the cycle. But right now we haven't enabled the DDT observation in Spotlight given the fact because it's 100 hours. So it is easier for GTAC to take care of it. So because when GTAC get and then definitely they're getting requests more than 100 hours. So they kind of feels like, okay, you right now give it only for the regular observation, and then we'll open it up for you open up more hour, then we'll give more hour for that, because you can preserve some hour for the DDT kind of thing. So yeah, so that is the way. So that when that comes, then the priority period is much less. But apart from all those things, I kind of tend to feel the way DSA is moving, that you make the observation and make the thing public. But Spotlight team will move towards that. But right now, the current thing is based on the GMRT policy of 18-month of preparatory period.
Makes sense. Thank you.
Anyways, we have 100 hours of open sky time, so feel free to just write a proposal.
Hello. Yeah, I think the discussion is really interesting. So India being a so populous country, and then you have like students everywhere, and they are always ready to do some projects, and either they are, and then there are so many nice ideas here as well. So it is just a point of curiosity for me. For example, if I'm in some college and I have like some groups, and we just want to build a small, a dish or something, might not be the best one, might not be able to like even see a FRB, but should I go ahead, like should the college go ahead and build it so that like it can act like some outriggers, or like help this project in any ways, like, because it's not just the yeah, that's the whole point. Like, should it be like the super high level, it's very sensitive and like industry grade and such stuff, or like I can help whatever I can? Yeah.
Who wants to take this?
I would like to Prabhu to answer the question actually, because he has been working with students a lot.
He kind of knew already.
Okay, let me answer this question. See, IISC, Indian Institute of Science, IITs, they developed electric cars many years back. Their aim was not to immediately drop that car in the road. There will be certain things so colleges should go ahead and develop. You don't have to worry about whether it is super best or not. A person gets trained and the human resources come up with what is required.
So no, my question was more like, how to get some guidance, or like, is there something should be set up in the country that, that helps these students? Not exactly in the sense that you guide them, make the project, because I know there are few limited number of people in the country who are like helping everybody out there. But it's more like, I can just ask. So if I want to like help in this, I just want some specifications, and then the group itself can like go ahead and build something for them. So in that sense, I wanted to mean. So is there what do you think might be a good solution for these colleges to communicate?
I think NCRA Ayuka had a radio astronomy lab, and there are institutes who are interested in doing it. People around the colleges and students around that place, they come and do. But I think one could focus such things in the coming years. But that'll be a different forum.
Isn't the SWAN project in basically doing exactly that? Isn't it like developing local expertise? Like, isn't that one of the purpose?
So it's more like, can we use like example SWAN? So can we like, is it a good idea to set up like a committee, like, and then if any outrigger goes like this, and then SWAN would be something like that? Yeah.
Raghu, are you talking specifically to FRB specific instruments?
Maybe, or like also LP. In general, I'm talking about the capability of Spotlight, so that we can use that everywhere, right? Like even probably long period transient, somebody just staring with like low resolution, low time resolution, probably because they don't want much, something like that.
See, I'll tell you, if one needs to actually develop the basic skills, not necessarily FRB. The best thing, a student cannot wait for a few years or months to catch an FRB. So the sun throws out solar flares every day almost this season. And if a simple capability to even detect those transients, the ideas can be applied, extended So one should look at what will make students excited, and then they wait for 6 months and see nothing. And so that's possible.
Any more thoughts? I mean, it doesn't have to be limited to this, but oh yeah, there's one there.
Hey, so I was curious about the last point about the milli arcsecond localization. So what are the potential out-trigger dishes, or has there been any communication with any of the other antennas to say coordinate for the out-trigger dishes? So is there any progress on that front? So that is what I wanted to ask.
I mean, are you talking about like existing radio dishes in India where you're trying to coordinate, or just in general in like the EVN, for example?
Yeah, it's more like a thing. Has there been any plan on like selecting some outrigger dishes maybe available, or maybe trying to bring it up?
I don't know, Jayanta or Franz or others. No.
I mean, one thing I've been thinking about is to what degree, Spotlight could be, or whether some of the dishes that we use in Precise could actually sort of also be used in a coordinated observation scheme with Spotlight, right? Because we do have 3-4 dishes that we use also for the single dish monitoring, and I could imagine that we use those to just shadow whatever the GMRT is observing at a particular point in time. Of course, we are not, with those stations, we're not as frequency agile as the GMRT, and we might not even be covering exactly the same band, so that's something to be coordinated. But that's something I could imagine. It's again somewhat of a pirate VLBI thing. So there's a lot of policies that go into this, so that one would have to be a bit careful. But yeah, I mean, there's also, of course, then the question with data proprietary periods and what the PIs are going to think if some other stations observe the same field, blah, blah, blah. So there's a lot of policy involved with that. If you use external facilities, right? If you do something India internal, where you sort of control the whole system anyways, I think that's easier. But I mean, GMRT is part of the EVN. So even there, I mean, with the EVN Lite project, I could imagine that one could go for an EVN Lite project where it's all about observation. If there is a trigger, if there is a detection, then you do the correlations. But that being said, of course, then you're involving EVN Lite, so that's more dishes than just 3, and then you're sort of bound in time again. You're not going to have as much time on Sky as what you do with the GMRT or with Spotlight, which is 24/7. So, there'd have to be a lot of technicalities to be thought about, but I think one can trigger that discussion and start thinking about how this could be done. And I'm certainly interested there. But with the 3-4 dishes that we have, Unsala, Torun, and Westerbork, trouble is, from a GMRT point of view, those are redundant baselines, right? Effectively, that's one baseline. And, you're not going to see much on those 3. If you have a faint detection at GMRT, you're not going to see anything between those 3. So you effectively have one baseline. But I don't know, something to start with, play and see. I could imagine that.
Yeah, I think, one of the things we also, I guess we have to be careful about is the LST coverage, right? Like Franz mentioned. So if you're too far away, then you're going to barely have any overlap on Sky to maybe monitor a particular source. So in that case, yeah, I guess that's something to think about as well. Yeah. Prabhu, do you want to say? Yeah.
The data analysis and availability for a larger community from question. I'm sure that the Spotlight members would take care of making the archives labeled and accessed from the beginning, because I know it's a lot of data and too much of metadata, and they all have to be. But I think the starting has happened already. We got a chance to actually use the tools that the team have been using to analyze the data. In some sense, the first day workshop was about that. So it is a community access already in place, And what one would need to probably take care is to make routinely, it's an everyday job because commensal observation, data comes every day. And there must be an automated archival system that one may need to think about it independent of how whether the data is good or bad, some kind of a bookkeeping mechanism need to be in place. And even though it's available later on for public, but even for internal use, if somebody comes into the NCRA accessing the data, that needs to be planned, I think.
DSA 2000 must have already thought about these things and are probably well on their way to solving a lot of these problems, right? Yeah. Okay.
Getting public, is it like the cutouts of the data where it's a transient setting? Is that getting public immediately with this make it is discovery of the or detection of transient? Okay. Oh, including baseband also. Okay.
Hello. My question to Jayanta sir. Here, back. Okay, so continue to this question. We have UT radio telescope. So, is there any plan or anything for including in spotlight or any similar thing? Because OT have a similar structure as a chime, and R1 is movable as well. So, is there anything?
I think like Visweshwar is here. So he is actually Visweshwar, and the group of team is working on that to make the UT live and can see the transient sources. So one of the things that if UT, there's a one good possibility, like in India, when somebody is looking for the amount of radio telescope what you have. So the main two is GMRT and UT, and UT is one part of the GMRT frequency, but it has a good sensitivity. It's almost like 4 GMRT dishes in terms of secondary. So yeah, so one possibility is that if you find if the OT is working at its expected sensitivity or close to that, then we can actually use that as a kind of out trigger station if the frequency happen to be the same. Yeah. So thanks. Yeah, Vishesh.
Yeah, I just wanted to add to that. Yeah, I mean, the UT telescope did suffer from some degradation in its sensitivity, and it's been revived. It's almost back to about 80% of what we used to have. And the other thing I wanted to add, and which I missed during the segment on the VLBI, is that we already have successful fringes with UT, between UT and GMRT. And so the aim is that going forward, we are able to do it more routinely. And so, Spotlight becomes a reason to do that. I think the best strategy, at least initially, would be to just, shadow observe with GMRT and see if, whenever there's a trigger, a similar trigger can be implemented for UT. It's not necessary to record every bit of the data. And then, one can try these things down the line. I think it makes sense. Yeah.
Right. I think we're almost at the end of the hour. Well, hour in the sense on the clock. Yeah, unless anyone has some,
I had a small
burning questions. All right, Ujjwal has a burning question or comment.
No, I just had a very small question. So MeTRAP has MeerLicht, right? Which is an optical telescope that shadows all the MeTRAP observations. So from your experience, how useful it would be to have something similar for Spotlight is what I want to do.
Very useful. Okay, we have had issues with MeerLicht, but those are like technical also because we also get clouded out every now and then. But I think I reckon the site, GMRT site is much better in the sense of, the chance of the night being clouded out is probably lower. I don't know. But it has been very useful because even if it can co-point during every nighttime observation with GMRT, you're basically getting contemporaneous optical coverage for free. And then you can also do other science with that telescope, where it doesn't have to be only limited to co-pointing, like people can also do other science. So, because the optical coverage for transients is going to be a very small fraction of the total time it will spend on sky, right? In theory, because these things are lasting for milliseconds. So, yeah, so I mean, I think it's a very useful endeavor if people should think seriously about it. No, I think it should be. I think one, if you think about, I mean, this is my opinion, of course. Feel free to chime in. If your first goal is to promptly get a deep image of the sky and at least figure out probabilistically what the host galaxy is, I think it's a very useful telescope to have, like a 1 meter, because you can also integrate for longer if it's something that's like, you know, a telescope that you have complete access to. So even if it's 1 meter, you can just integrate for longer and just, you know, go down to, you know, larger magnitude or higher magnitude depth. Or yeah, so I think it would be fairly useful for such things. And like I mentioned, because like I think Spotlight in terms of the sensitivity sits kind of in between, you have a good shot at like at least getting a potential host galaxy in the deep optical images, even with the 1 meter class telescope. But Sunil, maybe you want to comment on that.
Yeah, I mean, for what it's worth, PanSTARRS versus imaging survey with the 2 meter class telescope. So that data, which is as deep as PanSTARRS could have gotten, is already available. Not only that, there is, I guess, some amount of decals coverage because yeah, like I guess India is like closer to the equator, so we'll have quite a bit of overlap there with that field of view. So if you want just deep imaging of hosts, that data already exists for you for the most part. Though at least what you can achieve with a 1 meter class telescope, that you can do. What might be useful would be to look for like optical transients. So if you have high cadence imaging with that 1 meter class telescope, then maybe that could be adding some more information. So that sort of data is not available archivally. And yeah, if you can convince DOT folk to follow some of the, I guess, the sightlines that GMRT was going to be looking at, then maybe you could get contemporaneous spectroscopy. So that could be something that you could achieve. So that's a good 4 meter class telescope. Even with the low resolution spectrograph, you're going to get redshifts quite easily. So that should be something to be kept in mind.
So yeah, sorry, if there's a possibility to have a GMRT follower telescope, always point in the direction of wherever GMRT.
Yeah, I mean that was Jayanta's question, like Mirlicht is something that co-points with GMRT in nighttime. Yeah, so that was his question, if it would be useful. Yeah. So I think the answer is probably yes.
This is a commensal operations. The question that we should always ask, this is to the engineering team, are we using all, as much as direction as possible, all times? So the all times is within, you know, we have a pointing, we have a phase calibration, we have a variety of other engineering activities, and there is a dark day, black day, black slots. So these times are valuable in terms of the detection rate. So can something be done in a low profile, minimum antennas?
Now the detection rate is based on then what is the colored slot, because those are actually GTAC observation slots. So, but there is a good fraction, almost 30% of time is a black slot and white slots. So if we can use that, then the detection rate will go high. But we haven't right now considered. We only consider the GTAC approved slots, so that we can actually know that what fraction of time goes in GTAC, which is constant, and the band coverage is also constant. Only for whites and black slot, the band coverage is not constant because it can be any frequency of the band. Then it will be difficulty for us to predict the rate. So that's why you haven't used it. But if you start using it in practice, then definitely it will be something we should be work for towards. Yeah.
Controlled.
All right. Yeah, I think it's time. Yeah, thank you so much all for a very nice discussion. I think we got some very important, we realized there are some important things we need to think about in terms of how we take this forward. So yeah, thank you panelists, and thank you everyone.
We have time up to 4. So the plan is here that we actually did first 3 days of quite interesting different stuffs in the radio, then transient search, and then VLBI and optical. So this is 1 hour or almost like 15 minutes, 50 minutes is available, whether you wanted to pick up some of the hands-on session or ask questions while the coordinators are here, and wanted to specifically go through some of the thing which you think of doing it. So it's open to you whether there is any kind of feel from your side, whether there is particular topic you want to clear, or you wanted to clip this kind of this individual concern we can also address. So do you have anything which you wanted to go over, in which was missed or which you want to learn? So that's the way you can take it up. Yeah, anything on optical or VLBI, anything. I think transient search I covered very well in the first day, and maybe the radio imaging also we did the local interferometer. So I think that maybe it will come to either optical analysis, some of the host galaxy, or the VLBI thing. Any particular interest or questions?
Hello. Yeah. So regarding last session I came very late. I want to ask you one thing about the spotlight operating mode. That the FRB it will be a bright signature. So is it possible to like I could understand like giving more importance to the localization when you detect our FRB. So is it possible like pointing the dishes beams nearby to increase the space of search for the FRB? Like 30 dishes, you have some dishes pointing to the space, like nearby beams, not overlapping to make the milliarc second localization, but each dish is nearby around the central.
You mean putting more dishes? Are you talking about?
No, beams. Like each dish will have its.
Yeah, each dish has this or primary beam.
So you will be pointing in one direction, around that place. We're not pointing the each dishes. Anyway, you have sensitivity. These sources are like bright enough to get within one.
So currently the localization is slightly limited by the maximum baselines which you get out of it, which is like for us 25 kilometer. But actually in the so that's why the arc second imaging localizations come. So and then if that will change in the frequencies. If you go to the higher frequency, it will go to sub arc second because it depends upon the. So anything beyond that is limited by the baseline lens. So we'll not be able to get anything.
Yeah, I could understand. I'm not, so let's say I'm not, I don't want to be too precise about the position, but I want to increase the space for the search.
Yes.
So is there any way?
Yes, so you are.
Yeah.
So the okay, so you want to increase the field of view. So one way to increase the field of view is that we don't go for this. We are going for the phased addition. So one is the way to just go for the incoherent addition, and you get the full field of view. Okay, but your beam is less sensitive. The sensitivity is not that an issue. The issue is actually the incoherent beam is known to have a lot of interferences. So that whatever these people are talking about, like 1 trigger per minute or 4 trigger per 10 minutes, so that will be hugely different, because this all the lot of data we are actually able to process and get rid of these interferences because you do a phased addition, which will help us to, because the fringe rotation on the sky will actually dephase most of the RFI in practice. Okay, so that helps us to reduce the maybe 1,000 times the amount of triggers. So if you increase the field of view by incoherent addition, then that's we haven't done, because we will not be able to kind of accept and deal with that kind of rate. Okay,
it will result in more false trigger.
Yes. So another way is looking at that you add small number of dishes, and then the small number of dishes, when you add coherently, you have a little bit more beams. So it's the intermediate between the incoherent and full phased. So there is an intermediate solution where I have a small dishes. The thing is that when you add more dishes, the RFI decorrelate better. Okay. So you have to, again, if you add only small number of dishes and mostly those dishes are nearby, they likely to a possibility of that they will see same RFI environment. Okay, so then
it will result in small beam or small.
it will result little broader beam than the full addition of the all baselines, but smaller than the incoherent. So it will be in between, and then that kind of beam will allow you to get a larger field of view when you do tile with that kind of beam. But again, those beam will have little bit worse RFI situation, because of those nearby antenna you see kind of similar RFI environment. So we are actually kind of balancing between whether we want to get a beam which is pure in the sense like has less interference, or you wanted to get a larger field of view. So
okay, so one more, sorry. Is it possible to search for RFI in different direction with different dishes, like 30 to 25 if you have?
Yeah. So that is a kind of fly's eye mode you are saying, that dishes are putting in different direction. And that's what it has done in the ATA and other places. The thing is that in the commensal mode, we don't have a control where to look for. It's actually driven by the GTAC project. So and that all the GTAC projects is actually for a specific object, because they want to maximize the sensitivity of GMRT. And so we just look at the same objects. Yeah.
So even though so I do some observation for NPTA, so sometimes we will not use some dishes. So at that time, can it be used for the non-used dishes when we do the pulsar observation?
Yeah, you're saying that is it like the prime GTAC observation is not using the dish, or is the spotlight is not using the dish? Okay, so but prime GTAC observation never says that dish is not used means you will not point the dish towards the sky. So that all the GTAC observation, whether you are observing pulsar or continuum, they use the full GMRT available antenna. All of them pointed towards that direction, because we have two products, data products. No? One is the beam, another visibility. Visibility always take all antennas. Okay.
Okay.
So no matter whether your beam takes those antenna or not, because that products always have it. So in that sense, all 30 antenna will look at the same source. Okay. And we have to use those. We can decide in the spotlight. We can decide. I use 10 antennas out of 30.
Used to select only central square. That's why I'm asking the.
Yeah, but even if your project demand only central square, but the observatory will give you all 30 antenna.
Okay. So it is reserved for that slot.
Yes.
Okay. I thought we are not using, so it can be used. Okay, thanks.
Hello. I have a question to Kriti.
Kriti.
sorry. Okay, what was the question again? I'm so sorry.
Hi.
Oh.
Yeah. So in your talk, you were mentioning that you are facing some troubles when calculating the delay time distribution of host galaxies, especially some observational difficulties like obtaining the local star formation. So could you explain a little bit like what kind of specific issues that you're facing to calculate the DTD?
Yeah, so technically the challenge is very, like if you think about it, it's very easy. So let's consider the FRB that occurred in the globular cluster of M81. So let's take that galaxy and put it at redshift 1. It would be difficult for you to be able to comment on whether or not it involved a young progenitor channel or an old stellar population channel, right? So that was the primary idea behind saying that to put any constraint on the age of the source itself, you need to have a resolved star formation history of the galaxy. In the sense, if there's a globular cluster sitting right there, then you should be able to comment on whether or not the stellar population in the local environment is old or young, because you don't want to bias your measurement, right? So I guess another example could be if you take the recent localization, milliarc second localization FRB by CHIME. It's associated with a massive spiral galaxy, and the median stellar population age there would be like a couple of giga years. But then there's H2 star forming region sitting at an offset of, I think, 100 parsecs or so. So that puts a limit of 20 mega years instead. So that was kind of the motivation behind saying that all these traditional methods that use global star formation histories are not quite accurate when you want to do delay time distribution analysis. And you need to have resolved star formation histories to do that accurately.
So can't we use any IFU or any other techniques to obtain?
Yeah, so that's mostly the direction that everybody I think here is pushing in. So picking up a sample of FRBs in the local universe up to a redshift of 0.05 or 0.01. So that is basically a horizon beyond which you are unable to resolve typical star forming clouds or H2 regions. And then for the sample up to that redshift, you want to get IFU or like basically spatial resolved spectroscopy, and then put constraints on age of the source.
Thank you.
Load is there for any, and we'll actually lead to, I think we'll finishing in next 10 minutes, and we're going to end the school so everybody can go out and have coffee and talk chat. But I just wanted to understand that during the discussion, I just wanted to understand that this is something actually we're trying to do maybe not very often in India. Like we just try to understand, because as you understand, the first transient community is emerging pretty fast, and it goes over the all wavelengths. So this is actually, then you see last 4 days were really quite occupied with various flavors, correct? And it is, I completely appreciate it's not possible to everything in one day, every day. In some sense, we ran the VLBI imaging, radio imaging, VLBI and interferometer in one day, where each of them demands 1 week, correct? At least. So, but the thing is that it's actually an effort to understand, give you a flavor that these are the kind of things you need to do first transient thing, and hopefully follow up with little bit more focused thing. And so in each individual thing. So one thing which you can look forward, we'll share some kind of feedback from with you. And then the way we want this thing to happen, we try to capture it. So basically, they say, okay, no, maybe like we think, okay, we pick up one or few sessions on that and have it, because it's difficult to run a very long school, but you can run short school at different times. So that's one way of to look at it. So just please share your feedback. I will just share a form maybe by end of this week or next week, and then give your opinions how you should actually go forward next time. And that's one thing. And anyway, I think that's any immediate thing which you have, any questions for any of the speaker, anything who are present here. That also, do you have anything, any of you? Okay, if not, actually, anyway, next week if you are here, we'll have lots of talks. So, and I know many of you, all of you are here. Yeah, sorry. Yeah. It's a collaboration, kind of, that's the way BLBI designed. So you should have that, yeah. Yes. Yeah. Anything, any of you have any comments?
This is a naive comment to GMRT team. So I was wondering, like, is it possible to set some online school or where the people can detect some transient events in the archival data? Like, basically, I forgot the name of the program, but there's a similar program where people used to detect stuff from HST images and JWST images, like once it goes to public mode. So is it possible to do such kind of things? Like maybe create a community where people can, like amateur astronomers or any other people who are just interested to look into the data, can really do something that is quite productive.
I think that would be a great idea, and it actually also circles back to what Raghu had commented on setting up like reading clubs or maybe like small sections in IITs or any institute that's probably interested in doing such analysis. So an example I can give of is when I was at ITB, we had set up a small working group. The vision was to have something as big as like a small Mars rover team on a university basis. So I think the real bottleneck there is to find someone who's like willing to put in the time and effort plus money to get the group running. So that's something that we actually got stuck in when we were trying to set up a mini LIGO team at ITB. But if we could figure something out similar for any units where there's significant interest, then probably we can have like a small working group where people could be interested in technical aspects of building an actual telescope. Be another aspect where people are interested in doing the data analysis, and they can take such public data sets to search for transients and build algorithms and so on.
Yeah, if I might just add to that, I mean, NCRA has a lot of workshops usually talking about various aspects of observing in radio and like analysis of radio data. But I think what would be super useful in this regard would be a workshop where NCRA is focused on showing people how to deal with their archives and analysis of archival data specifically. So a detection of transients, it could be a simple matter of like looking for, you know, the dispersion sweep in in time series data, right? So yeah, it could be something.
So a follow-up, like not a question, probably it's a kind of a discussion, because I mean, so to do such things, we need to have time series data then. So is Spotlight ready to save all those time series data and such things as like, and also make them available publicly, which would be like a huge task, right? So
yeah, so in the Spotlight, there's a data product. One is the 160 beams, which I think Jyotirmay also mentioned. So that 160 beams is getting saved, okay, and we are not deleting them. Okay, so that data we will be archiving for some time unless until we actually filled up the disk pretty fast. So that data can be shared and basically can be used for some of the learning and things. And but I think what Sunil is mentioning, because GMRT has like 15 in 20 years of archive very fast, because there's like that is where we're searching for the long period transient. These are like seconds of resolution, but they are good to search for slow transient. So that's the kind of data set we can think of setting up like kind of a workshop or school where basically we can go through that how to process the data set, and it will be very good to have a community efforts, because that will speed up the processing thing, and then we'll be able to, because data is keep on getting piled as we are speaking, data is getting coming, yeah, correct. So and we are only limited by the resources or the people who can search through the data. So it will be definitely help opinion of that, at least the data which are older than 18 months, anybody can, as long as people are kind of know what are the tools to use and how to deal with the RFI, people can process it, correct. So that's something I think we should.
Yeah, and I guess one more direction to think about in that regard would be to have a Zooniverse project. So this is something that a lot of groups have been doing in various parts of the world, and it basically boils down to giving citizens a snippet of some data with some diagnostic plots and asking them whether a simple yes or no question, whether like, is there an FRB over here in this data? And most of the time the answer is no, but like this is super interesting to do for someone. You know, it's almost like a pigeon pecking experiment sort of thing. Like you just click yes or no. And you're actually contributing to building up a nice training data set for further ML applications and efficient searches through all of your archival data. So yeah, Zooniverse project could be something that maybe even students could come up with and build.
Further comments? Yeah. No, yes, yeah, we'll do that, but I think maybe, okay, thanks. Yeah. But I just wanted to say something like it is actually very nice of Kaustubh, Franz, Kriti and Sunil to spend time, and you have seen that how difficult it was to take us through all these things. So special thanks for them to help to organize the school. And to all of you who have taken the pain to download the Docker, run it, failed, and then again try again, and finally successful. So all of you. Yeah. And then all the students who actually is running, some of them are here, some of them are maybe coffee outs, but to all students who are working much before this thing to happen, to set up the Docker, midnight, in late night, they're working together. So all. Yeah, yeah. Okay, then we'll break and we'll meet you morning on the Monday.